Yes, so today I'm glad to present one of our studies that was included in my PhD thesis, sequential production of two oil fields with an option to switch. And in this paper, we're trying to address one of the challenges that exploration and production companies face right now on the Norwegian continental shelf, is that we have about 100 new discoveries, and a large part of them is not even being evaluated for production because there are still no solutions to make them commercial. And one standard solution is to connect small discoveries to existing infrastructure in order to improve the economics of the overall project. But is there a way to develop standalone small fields in a economically viable way? And in this paper, we're trying to answer this question, how to develop small fields if the infrastructure is too far away from existing platforms. So we assume that we have a single production unit to develop multiple discoveries. And in this paper, we take an example of two discoveries, which are field A and B. And what is natural to solve in this problem is to, first of all, evaluate if the sequential development of these two fields is better than develop them in parallel using the two production units. Then we should decide the optimal sequence, whether should field A be the first one to develop or field B. And then we should decide when to shut down field A and move the facilities to field B. And in our paper, we focus on a first and the third task because we assume that field A and field B are identical in the paper and are both represented by the Olympus benchmark case. This is the reservoir benchmark, which was developed about 4 years ago by scientists in order to test different optimization technologies in order to optimize the oil production from this field. And within Olympus benchmark, we have 50 probable realizations of oil production, water production, and water injection. And we apply well-controlled optimization in order to obtain these 50 probable scenarios of the production rates from this field. But the reservoir uncertainty is not the only source of uncertainty here. We also have the oil price uncertainty and the capex uncertainty, which mostly represents the capex to switch between field A to field B. And basically what we do in the paper is that we compare, first of all, two development strategies, the parallel production and the sequential production. And then we have two different approaches to evaluate the sequential production. We test the myopic approach and the options approach. And in the myopic approach, when we perform the simulation, we assume that the decision maker switches from field A to field B when the field A is fully depleted. And it means that when the field A reaches the negative cash flow, we switch, no matter what, no matter how costly it is at the moment, no matter what is the level of the oil prices when we decide to switch. And the second approach is the options approach, where we assume that we might want to switch earlier than suggested by the myopic approach, because we will learn something about the capital expenditure to switch, we will learn something about the oil price, and we also assume that we can invest in further appraisal of field B while we're producing field A in order to know better what we can expect from field B. And then if the appraisal program says that it is expected the field B's production potential is high, we might want to switch earlier to field B. And the strong assumption that we make is that from this appraisal program we have perfect information about the future recoverable reserves of field B. But we will test this assumption in sensitivity analysis. So in options approach, we have the switching time optimization problem. This is the problem where we should decide whether it is better to switch now or wait for another year to produce field A. And there are in overall 5 factors that affect the decision to switch. It is the field A production rate, expected production rate of field B, the level of the oil price, capex to switch, and field A's OPEX. And the option approach can capture the moment when we want to switch earlier. If, for example, field B has a much larger production potential than field A, if the capex to switch are currently low but are expected to grow in the future, and if, for example, field A OPEX is too large and we want to switch as soon as possible to field B. So we apply this optimization in order to see in what simulation cases we want to switch and in what simulation cases we are postponing this decision to switch. So these charts represent, the dots here represent every simulation case, and we had about 10,000 simulation cases, and we assume that we are in year 15, and these are the cases where the option to switch is still available. It means that by the year 15 we're still producing the field A. So on a left-hand chart we have the field A annual cash flow on the x-axis, then capex to switch on y-axis, and field B expected reserves on z-axis. And we can see that the red dots are simulation cases where we decide to abandon field A in year 15 and we leave field B undeveloped. And I should have mentioned this, that in options approach we also have the option to leave field B undeveloped if the conditions are unfavorable in order to invest in field B. So we can see that the decision maker tends to abandon field A and leave field B undeveloped when the field A annual cash flow is low and when expected reserves of field B are also low. This is expected. But green dots are those cases where we initiate switching from field A to field B in year 15. And this happens when the field A produces rather low cash flow and capex to switch is also rather low. This can be seen on the right-hand figure that the green dots concentrate right here where the capex are not very high. But the black dots are cases where we decide still to produce field A, and it happens when field A still delivers quite a lot of money, and we will revisit this decision next year. So there might be some cases, there will be a lot of cases where we decide to switch next year. So the result of this optimization is the optimal time to switch between the fields, and we can see the comparison of the distribution of the optimal switching time between field A and field B in a myopic approach and options approach, and we can see that the options approach suggests usually an earlier time to switch, approximately by 1 or 2 years. In most of the cases, the decision maker can sacrifice some production in field E in order to optimize the overall development project. And the first task that we made is we compared the parallel production where we have 2 production platforms in order to develop them in parallel. And we can see that any type of the sequential production is better than the parallel development. And we can see that under the options approach, we identify some additional value of this strategy. which means that it is quite important to use real options thinking when you have this kind of a problem. So as I said, we have an assumption that the field B reservoir information quality is perfect, and which means that it equals 1. And we can see that the percentage value that was added by the real options value compared to the myopic approach was in this case about 11%. But if we decrease the quality of the information that we receive after the appraisal program about the field B reservoir size, so we have imperfect information about the field B reserves, we can see that the value of the real options approach decreases because it becomes really difficult to identify better when the optimal time to switch. So the algorithm misses a lot of cases where it is optimal to switch now rather than later, or the way around. And we also tested the sensitivity to the correlation between the oil price and capex, and we see that it is highly important to account for this correlation because in a base case we had a correlation of 0.8, and we had this additional value created by the options approach. But if we didn't account for the correlation between capex and oil prices, the option value was overvalued. So the conclusion was that the sequential production can become an alternative way to the existing methods to develop small discoveries, and even standalone small discoveries can be developed economically efficiently. So it is important to account for the value of information that this decision maker will have in the future when making the switching decision. And the real options approach is needed to properly estimate the value of this flexibility. And also accounting for the correlation between capex and the oil price in such problems is highly important and can influence the project value quite significantly. So, thank you.